Hi guys, so today we want to look at the inverse of a 3 by 3 matrix. So we were given a matrix P equals to this. Okay, the question says find P inverse, that's the inverse of P, and then the B part says show that this multiplied by this gives us this. So for us to get the inverse of a 3 by 3 matrix is simply giving us, sorry, let me take this off. P inverse equals to the adjoint of P divided by the determinant of P. And now what is adjoint? Adjoint of P is simply giving us the transpose, of the cofactors of P. Okay, so that means the first step I would like to take is to look for the determinant of P. So given matrix P, the determinant is simply going to be, I'll pick 1. Remember, if you've not seen the video on determinant of a 3 by 3 matrix, I'll advise you watch it because we're going to be applying straight away all what we've learned there. So I'm just going to go straight to working on them. So we have 1, 2, 1, 3. And I have 0, 2, 3, 4, 1. And I have plus 2, 1, 4, 2. So this is going to be 1. This is 1. 1 times 1 is 1. Minus 2 times 3, that's 6. So minus 0. This is 2 times 1 is 2. Minus 4 times 3 is 12. Plus 1. 2 times 2 is 4. Minus 4 times 1 is 4. So that's what we've got. Then 1 minus 6 is minus 5. While 2 minus 12 is minus 10. Plus 1. This is 0. So we have that this is going to give us 1 times negative 5 is negative 5. This times this is 0. So just write plus 0. And of course, this is also 0. So the answer is, the determinant is minus 5. So next we're going to look for the cofactors of matrix P. So what we just simply need to do is to, let me rewrite it. We have matrix P here: 1, 0, 1, 2, 1, 3, 4, 2, 1. Now, matrix P, for cofactors, they need to be represented in this form. We have plus, minus, plus, minus, plus, minus, plus, minus, plus. So looking at this now, for this particular element, row 1, column 1, we have plus 1, 3, 2, 1. And then we have, for the row 1, column 2, we have 2, 3, 4, 1. For row 1, column 3, we have plus 2, 1, 4, 2. For row 2, column 1, we have minus, that's for this, we have minus 0, 1, 2, 1. Well, for this, we are picking this. So we have plus 1, 1, 4, 1. Then for this, we're picking this. So 1042. 1042. One zero four two. Then for this, we're picking, that's for this, we're picking 0113. 0113. While for this, minus this, we're picking 1123. 1123. For this, we're picking 1021. 1021. So all we need to do now is to use this. We just need to get the determinant, okay, of each of these square matrices. So let's go now to get the determinants. Maybe I should just do it somewhere here. For the first one, we have 1 times 1 is 1. So we have 2 times 3 is 6. So that gives us minus 5. So minus 5 times loss is going to give me minus 5. So that's for the first one. Then for the next one, I am going to get 2 times 1 is 2. 4 times 3 is 12. So I'm going to get 2 minus 12 is minus 10. Minus times minus is plus. So that's going to give me plus 10. Well, for the next one, I'm going to get 2 times 2 is 4. 4 times 1 is 4. So this is going to give me plus 0. Then for the next one, I'm going to get 0 times 1 is 0. 2 times 1 is 2. So that's minus 2 times minus. So it's plus 2 we've got there. This is going to give me plus 4. 1 times 1 is 1. Minus 4 times 1 is 4. So this is going to give me minus 3. Well, this is going to give me 1 times 2 is 2. 4 times 0 is 0. So this is going to give me minus 2. Then this would give me, for this, I'm going to get, let me move this up. I'm going to get 0 minus 1. 0 minus 1, that's going to give me minus 1. Then for this is going to give me 1 times 3 is 3. 2 times 1 is 2. So 3 minus 2 is 1. So this is minus 1. Well, this is 1 times 1 is 1 minus 0. So this is plus 1. The next thing I'm going to do is to write out the cofactors that I just got. So I'm going to say cofactors of P are, so we have minus 5 plus 10, and we have 0. Then we have plus 2, minus 3, and we have minus 2. Then we also have minus 1, plus 1. So minus 1, plus 1. So these are the elements of the cofactors of matrix P. Now remember, we said for us to get the inverse of a matrix, it is giving us what? The adjoint of matrix P over the determinant. And we also said that the adjoint of a matrix is defined as the transpose of the cofactor. So I'm going to get the transpose now. Let's get the transpose. Transpose of matrix P. Sorry, transpose of the cofactor of P is going to be, now to transpose a matrix simply means make all of the rows the column and make all of the columns the row. So minus 5 plus 10 and 0, that is the first row, is now going to become my first column. So minus 5 plus 10 and 0, while the next one is going to be plus 2 minus 3 minus 2, and finally we have minus 1 minus 1 plus 1. So this is the transpose of the cofactors. Then the next thing we'll do finally is to divide this by our determinant. Remember, we got the determinant to be what? Minus 5. So we're dividing minus 5 plus 2 minus 1 minus 1 minus 3 plus 10 0 minus 2 and plus 1. We're dividing this by 5, which happens to be the determinant. So I'm going to write 1 over 5. Sorry, minus 5 actually. So that means inverse is simply going to be my inverse is simply going to be minus 5 divided by minus 5 is plus 1. So I'm going to get plus 1. Then this is going to be, this divided by this is going to give me minus 0.4. This is going to be 0.2. This is going to be 0.2. This is going to be 0.6. This is going to be minus 2. This will be 0. This will be 0. This will be 0.4. And this will be minus 0.2. So this is the inverse of the matrix P. So all you just need to do is to follow the steps and you'll be able to get the solution to the problem. So let's look at the next question. The next part of the question says, show that the product of P and the inverse of P gives us the identity matrix. So P is 1, 0, 1, 2, 1, 3, 4, 2, 1. This is matrix P, while the inverse of matrix P is 1, minus 2, 0. Then we have minus 0.4. We have 0.6, and we have 0.4. Then 0.2, 0.2, 0.2, 0.2, and minus 0.2. So let's quickly multiply. So this is going to give us 1 times 1 plus minus 2 times 0 plus 1 times 0. Yeah. Then we also have that 1 times. So this, what we just finished doing was this. So we're going to go to this 0.4 Okay, so 1 times 0.4 plus 0 times 0.6 plus 1 times 0.4. Then we also are going to do 1 times 0.2 plus 0 times 0.2 plus 1 times 0.2. Sorry, this is actually negative. Okay, then I'm going to go straight to the next one. The next one is, let me move this up a little bit. So the next one is 2 times 1 plus 2 times 1 plus 1 times minus 2. 2 times 1 plus 1 times minus 2 plus 3 times 0. Then 2 times minus 0.4 plus 1 times 0.6 plus 3 times 0.4. Then we also have, for the other column, 2 times 0.2 plus 1 times 0.2 plus 3 times 0.2. Also, we have 4 times 1 plus 2 times minus 2 plus 1 times 0. Also, 4 times minus 0.4 plus 2 times 0.6, 2 times 0.6 plus 1 times 0.4. And we have 4 times 0.2 plus 2 times 0.2 plus 1 times 0.2. So this is actually negative, sorry. Negative 0.2, negative 0.2. So finally, all this needs to be, so 1 times 1, 1, 1. This is going to give us 1. This is going to give us everything here. Since we're multiplying by 0, it's going to give us 0. Since we're multiplying by 0, we're going to get 0 here. So this, there's a 0 to be multiplied by, so we're going to get 0. While this is going to give us 1. This is going to give us 0. This is going to give us 0, 0, 1. So at the end of the day, this is an identity matrix. That's what we call an identity matrix. So we've been able to show that when a matrix is multiplied by its inverse, it gives us an identity matrix. Yeah, so that's it.